Space Station's Communication System. Space Station's communication system is a critical component that enables the exchange of data, voice communication, and other information between the space station and mission control on Earth. The complexity of these systems is driven by the need for reliable and efficient communication in the harsh environment of space. Here are key aspects of a space station communication system: antennas and tracking systems. Space stations are equipped with high-gain antennas for communication with ground stations on Earth. These antennas are often parabolic in shape and can be steered to track the movement of the space station and maintain a stable communication link. Frequency bands. Communication signals are transmitted and received using specific frequency bands allocated for space communication. Different frequency bands are used for uplink communication from Earth to space and downlink communication from space to Earth transmissions. Data transmission. Space station communication involves the transmission of various types of data, including telemetry data, information about the status and health of the spacecraft, scientific data, and communications with the crew. Data rates can vary based on the type of information being transmitted. Telemetry and command systems. Telemetry systems continuously monitor and collect data on the spacecraft systems, including its health, position, and status. Command systems allow mission control to send instructions and commands to the space station. S-band and Ku-band communication. S-band and Ku-band frequencies are commonly used for space communication. S-band is often used for telemetry and command functions, while Ku-band is used for high data rate communications, including video and scientific data transmission. Communication protocols. Communication protocols define the rules and conventions for data exchange between the space station and ground control. These protocols ensure reliable and standardized communication. Tracking and data relay satellites (TDRS) for continuous communication, especially during orbital phases when direct communication with ground stations is not possible. Space agencies deploy networks of tracking and data relay satellites (TDRS). These satellites act as relay stations, providing uninterrupted communication coverage. Phased array antennas. Some advanced space communication systems use phased array antennas. These antennas can electronically steer beams without physically moving the entire antenna, allowing for rapid and precise adjustments in communication direction. Intersatellite communication. Certain space missions involving multiple spacecraft or satellites. Intersatellite communication systems are employed. These systems enable communication between different components of a mission or between satellites in a constellation. Security measures. Communication between a space station and Earth must be secure to protect sensitive information. Encryption and other security measures are implemented to prevent unauthorized access and ensure the integrity of the communication link. Emergency communication. Robust emergency communication systems are in place to handle critical situations. These systems ensure that, in the event of an emergency, the space station can establish communication with mission control promptly. Ground station work. Ground stations are strategically located around the globe to maintain continuous communication coverage as the space station orbits the Earth. These ground stations work together to provide seamless communication during the entire mission. In summary, the communication system of a space station is a sophisticated network of antennas, transmitters, receivers, and protocols designed to facilitate reliable and efficient communication with mission control on Earth. The continuous improvement of communication technologies contributes to enhanced capabilities for scientific research, crew interactions, and overall mission success.